Today's webinar is based on a report by the Pacific Northwest National Laboratory, and you can find the full report as well as the 4-page findings and 1-page infographic at gsa.gov/GPG. And that report is fresh off the press. It was just posted yesterday, and we'll be sending out an email shortly as well with an overview of those results. Next slide. Today's webinar will be recorded, and all recordings and slides are available also on the gsa.gov/GPG website. We'll also be sending out an email post-presentation, and that'll have the top Q&A as well as links to the webinar recording and presentation slides. Next slide. Today's webinar is one in a series, and our next webinar will be on January 17th. Where we'll be presenting results from several years of research looking into alternative water treatment for cooling towers. With GSA water rates increasing 41% in the last several years and cooling towers accounting for 28% of commercial building water use, these technologies that have been shown to save water are particularly promising. We look forward to your participation in this webinar as well. Next slide. All GPG webinars offer continuing education credits. Carolyn, we want to go back a slide. To receive credit, please complete the post-webinar survey, which you should all receive. If you don't receive the survey, please reach out to Michael Hobson. Today's broadcast is set to listen only for participants. If you have questions, please use the chat box there at the right side of your screen, the lower right side. And you don't need to wait until the Q&A at the end of the presentations. In fact, we encourage you to submit your questions well in advance of the Q&A. And with that, I'd like to turn it over to Jay Fine. Next slide. And Jay was the project manager for the evaluation.
Thank you, Andrea. Good morning, everyone. Thank you for joining our presentation today. So as Andrea mentioned, I was the project manager for the evaluation portion of the presentation you're going to hear today. I think of my role today in this presentation, I'm kind of like the sandwich bread of the presentation. You're going to hear from me now at the beginning, and then I'll come back around at the end and close us all out with questions. And in between, you're going to hear a lot of meat about what happens. Okay, next slide, please. All right, so here's what we have for agenda. First up, you're going to hear from Kevin Powell, who's Program Manager of Emerging Building Technologies. He's going to tell you about what we do in emerging building technologies and then kick off the introduction for the evaluation for today as well. And then you're going to hear from Michael Meyer, who's from Pacific Northwest National Laboratory, and he's going to tell you about the evaluation itself. So it's advanced lighting controls with LED lighting. Typically in that role, we bring on what we call the principal investigator, the person who was involved, who did the actual, set it up and did the evaluation through the whole process. That person who did it for us on this technology evaluation retired as soon as the draft report was complete. There was quite a bit of work left after that, and Michael Meyer stepped in, quickly learned what we're doing, has done a fantastic job of getting this over the finish line. So you're in for a real treat. This is going to be a really great presentation from Michael. Following that, we do what we always like to call on-the-ground feedback. So we have two of our outstanding team members, Frank Campagna and Stuart Lampkin, who are from GSA's Region 7. They were involved in the actual installation, dealing with the customers. They're going to tell you a little bit about the technology, what was good, what they had issues with, what was a struggle, what did the occupants think. And then after that, I'll come back and I'll do Q&A for 20 minutes. I'll facilitate that for you. I want to reiterate what Andrea said, which is we're not going to unmute your phones. You can't talk. It's too hard with the number of people that we have on this call to have people talking and asking questions. So what we do is we provide you this great opportunity. You just put in what you need for a question into the chat box, which is at the lower right-hand corner of your screen. We'll capture those, and then at the end, we'll go through it and do those. I do encourage you the same thing. Put them in as soon as you think of them, because one, you're going to forget them if you don't put them in, and two, we answer questions typically in pretty much in the order that they're received. So if you have a question, put it in there to make sure we have time to get to it. Okay, next slide, please. And with that, I'm going to turn it over to Kevin Powell.
Thank you, Jay. And next slide. So a few words, I think, for those of you who are not familiar with Emerging Building Technologies program at GSA. We established this program in order to help our agency make sound decisions in next generation technologies. That is to say, there's a great deal of innovation out there, and we're going to in fact talk about one very, very good example of that. And the question, though, that we need to ask ourselves is, in the real world, does it deliver the claimed energy savings or water savings or other improvements that manufacturers tend to talk about? And then in addition to that, can we install it? Can we operate it? Do tenants like it to the degree that it affects them? And perhaps most importantly, does it really have return on investment for us? Because we can't do things that don't have that. The other piece that we've increasingly taken as part of our program is the cybersecurity aspect of these technologies. And of course, what we're going to talk about today has fairly significant cybersecurity impact. One of the things that we always want to have as an outcome of our program is to know that, in fact, this technology not only delivers all of those performance benefits that we just talked about, all of the user and operator acceptance, but also can, in fact, be cyber secure on our building systems network, which, again, should give everybody on the line confidence that this technology can deliver for GSA and for others as well. Next slide. So just a couple of notes about what this technology is and why we chose to select it and where we think it might be headed for us. I think everybody is pretty aware that next generation lighting is here, right? LED lighting is here. We have it in our houses. We have it in our offices. It's just incredibly more efficient. Well, there's some other aspects to LED as well. One of those aspects is that it is inherently controllable. It's essentially a computer. So because of that digital nature, because of that controllability, the question then becomes, what's the value proposition of those controls? How do you do controls well? Do they have return on investment? And there's a number of different ways of, it's actually topologies of controls, which of those deliver the greatest bang for the buck. And in fact, the next thing that we're doing in the Emerging Technologies program is developing a business case around 3 technologies that will have, that based on some work that a company called Guidehouse did for us. They used to be called PricewaterhouseCoopers. But their research found, of all the technologies that GPG has looked at, they racked and stacked and said, here are the top 3, and in fact, advanced lighting is one of them. So that, again, we'll share that internally, at least with GSA folks, when that is complete. So with that, I want to turn this over to Michael Meyer. So next slide.
So, thank you, Kevin. My name is Michael Meyer. I'm with Pacific Northwest National Laboratory. We're one of the Department of Energy 17 national labs, and as some of the work we do for the Department of Energy is energy efficiency, as well as measurement and verification and analysis. We partner with GSA a fair amount. Next slide, please. I also see many of you already putting questions in your command in the question pane. Thank you for that. I will try to touch on them as we go. As definitely will also touch on them in the Q&A. So the first is, I think it's great to talk about energy savings as well as some terms. So first, advanced lighting controls. What does that usually mean? There is a wide range of things when we say lighting controls. The first thing when we say a lighting control, at its basic core, we mean some mechanism that is modulating the light. That means it's either turning it on and off. It could be as basic as a time switch, or it could be even more advanced. Advanced lighting controls typically mean they are multiple types of sensors. So it is not just a occupancy sensor. It is not just a daylight sensor. Often they are either the same sensor in the same physical sensor housing, or they're grouped together. And then as you move into levels of either complexity or advancement, we'd say, they can become what's called networked, meaning that you have a standalone network within a room or a building where they are able to talk to each other for commissioning and other energy reporting needs. And then you can move up to really truly next level cutting edge advanced lighting controls where they might actually be talking outside the building. So I see a fair amount of questions asking about secure facilities and advanced lighting controls. So the first thing I'd say is that these were all more in the neighborhood of the networked family of controls. None of these spoke outside the building. And so that changes your level of security and risk. And we'll talk about these later at the Q&A. But so the first question is really, how advanced is this? So this is in the medium advancement, not as super advanced as it can be, but GSA is testing out that technology as well. I think it's also worth talking about energy savings. So yes, as Kevin mentioned, and I think most people on the phone are aware, LEDs, they save energy. However, lighting controls really can help you take you to the next level and save you additional energy. The slide here is showing a huge range, 25 to 75%. And the reason why that is that your energy savings are really going to depend on your occupants in your building, as well as your building type. If you happen to have a building without any daylighting, you won't be able to save any energy that way. So that's one reason why that value might be on the low end. However, if you have a building with ample amount of daylight and possibly not continuous occupation, you might be able to take advantage of occupancy sensors coupled with the daylighting sensors. So we usually use these big ranges just to give us a lot of leeway. In general, that 30 to 40% is probably throwing a dart at it, right, probably what you're going to get without people even knowing anything about it. That 75% can really be in a range of certain types of spaces. So we'll talk about more in a second. The other challenge that we see is that really, sadly, not enough buildings use controls. Roughly about 2% of all commercial buildings implement advanced lighting controls, and controls themselves are only in about less than 20% of all buildings. GSA P100 recommends and encourages the use of lighting controls. A lot of the energy codes also require them. Controls are just beneficial in that they add variability to the space and they add energy savings. It's just that there are some challenges to using them, and a lot of sometimes the cost throws them off projects early on. We'll talk about that also in a second. Next slide. So we'll discuss the types of lighting controls assessed first. This is a great graphic that GSA developed that I'm a little jealous of because and I like it so much that I'm probably going to start stealing it from them. The first thing to do is talk about what we mean when we say controls. So again, these were the three types of lighting controls that were assessed in this project. The first being light level tuning, and that's really well shown on the first one, fixture starting from the left. You can see the rectangle in the ceiling suggesting that there's a light fixture there, but it's not as bright or as dark yellow as the one to the right is. And the idea is that that's light level tuning. And the idea of light level tuning is you install a light fixture in many of the spaces, but it may not need to be as bright in that space as another area. And there's multiple reasons why, either occupant preference, meaning that the type of work that goes on there may not need that same high light levels. Or it could be that the computer terminals or other things are bright enough and they actually don't want it so bright. A lot of coding rooms and a lot of database rooms, they tend to not want it too bright. So you might do light level tuning. So that's just where you reduce the output from what it came at the factory setting. You can also have that done at the factory, and there's different ways to do it. But basically, it's just that you're reducing the output of some amount. Next is occupancy sensors. Most people are probably pretty familiar with occupancy sensors. The idea here is that when you leave the space, the output reduces either to low output or completely off. These are really effective in corridors and restrooms. In offices, they have mixed effect. In a private office, they're really effective. In an open plan, they can have a challenge. If you happen to get up from your desk often, the person next to you might be frustrated with it going up and down a fair amount. So with occupancy sensors, the low output setting is something you need to pay attention to, which can affect your energy savings, as well as the amount of time that it takes before it reduces to low output. Both of those are things that can affect your output, your energy savings. Finally, then we have daylight harvesting. The graphic here with the daylight coming through the window shows it we all know how that works. The idea here is that when you have a well daylighted space, there's ample amount of daylight in the room providing a sufficient illumination that the electric lighting overhead can then reduce in response to the amount. So again, you save energy that way as well. I'm going to stop here for a second. So for light level tuning, typically when we say light level tuning, this is done at the commissioning time. And for those who may not be familiar with the term commissioning, this is after your equipment's been installed and you have a commissioning agent come around and they set the output and they make sure all the controls are working the way they're supposed to be. They do this on HVAC all the time, and in lighting they should be doing it as well. Typically when we talk tuning, we mean that it's done at kind of a high level. So someone comes through either and does it with a handheld remote, or they do it through a interface at a terminal. And they typically set that level kind of at one point, it's a static level, and it stays that way for a long period of time. It can be adjusted at some other time by, if you, let's say you had occupant turnover or you reconfigured your office, somebody on the O&M side could come in and redo that. There's another type of call that's called personal tuning, and in some cases, GSA offices have tested that out as well. The concept is that you have essentially like a handheld dimmer at your desk or an interface through your computer terminal where you can dim the light fixture just for yourself. Those are less typical because you really need to know your office design to make that effective, and if you change your floor plan layout, they may not always succeed. So typically when we say tuning, we're talking what we call institutional, which means more kind of the space consistent, either the room or a section of it, whereas personal tuning, you can do it yourself. So those are the different types of terms. Next slide. So this was at the Fort Worth Federal Center. There's two pictures here. One is the exterior, and then the other one is a nice shot of the ceiling plane from the interior. There was a number of light fixture manufacturers and control manufacturers who participated in this demonstration. Their names are across the bottom. Lighting industry's had some turnover in the last couple of years with companies changing names, buying companies, and things like that. So in this case, Philips is also known as Signify now, and Intellium now became Flow Lighting. One of the things to know about this facility, and you can kind of see it on the left-hand picture, is that the building didn't have a fair amount of daylighting. I shouldn't say that in double negative. The building didn't have a lot of daylighting. As a result, daylighting controls were not entirely effective, which is fine. Each building's different, and they're designed for the needs of the occupants and or the function of the building. So not every building is going to have daylighting. Next slide, please. This is just a quick map to get a sense of what we analyzed. The zones were just determined, and they're typical in size. They're similar in size. Some of them are on the perimeter. Some of them are interior. You can see the kind of funky Tetris-shaped block one. That's Zone 7. That was a hallway one. We also tested the mezzanine. As a result, they're not all directly comparable. Obviously, the larger blocks that are more rectilinear, those are typical, whereas the hallway one has different behavior. So not all of the comparisons are always directly the same. Next slide, please. So it's good and important to always talk about illuminance. Those who may not be familiar with the term, illuminance is the amount of light falling on the light on a surface. You can see in the top row here the baseline fluorescent values. They're in the mid-30s to mid-40 foot candles. In contrast, you can see in the second row the tuned LED foot candle values. Other than Zone 4, they're pretty comparable. The bottom row is the light level change. The tuned light levels really were in response to occupant preference. Ideally, you should be matching either P100 recommendations, at least from a starting point with your design. Make sure you have the correct equipment in there that you can meet those. But then you might want to adjust to meet the different functions in the offices. In case of Zone 4, there was some occupant discomfort with the new lighting, and they had actually put up visors that had blocked it until they retuned them down to their light levels. Now, again, that's really more based on the specific occupants in the space. Similarly, tuning can work the opposite way if you have a section of an office with people with visual problems or older staff who might need just a little more light. They may not choose to tune. So it is really dependent on who's in the space. So someone asked a great question here about light level tuning changing industry attitude towards ambient illumination and going from absolute foot candles to contrast ratios. Contrast is a very important thing to focus on. Illuminance is really just a snapshot, and it's an easy way to think about something. Contrast ratios are really kind of how bright the visual appearance of the space is. You ideally want roughly a 3-to-1 contrast ratio. That's because your eye can't really see a difference between 3-to-1. And so it is important that when you are examining a scene, you're not thinking of just the one value. You're really examining the entire space. Next slide, please. So this is just a graph of measured energy use. This might be a new metric that for lighting that not everyone's familiar with. The charts are in energy use intensity, so that's just kilowatt hours per year per square foot. It allows us for some easy, quick comparisons between building types. When we use big numbers, let's say 200,000 kilowatt hours or 1 million kilowatt hours, it's not entirely comparable on some levels. Sometimes those numbers become meaningless because they just become so large. But what is important to understand here is that the building did have some fluorescent lighting that was not entirely operating, or not all the lamps were operable, and so therefore we had the two different baselines on the left, 3.8 and 3.5 kWh per square foot. Then you see the next reduction from the fluorescent baseline to the LED baseline, going to about 1.9 kilowatt hours per square foot. Now this did coincide not only with converting to LED fixtures, they also reduced the fixtures as a result, partially because of better distribution from the LED fixtures compared to the fluorescent fixtures. Then the next step is to convert to, or not convert, is to tune the LEDs. This is the normal step in the commissioning process. So again, you see the energy savings or energy use intensity decrease, which results in savings. And then finally, the tuned LEDs operated with occupancy sensors. So you can see a significant reduction of roughly 2/3 the energy use intensity by going to LEDs with the advanced lighting controls. Next slide, please. So this is just a kind of a quick graphic so you can understand really where all the savings occurred. This is against the LED baseline. It's very important to kind of pay attention to the different baselines that I'm mentioning. Previously I said there was roughly a 2/3 reduction. That was against the fluorescent baseline. So the reason why we're focusing here now on the LED baseline is that, well, everybody's pretty comfortable with going to LEDs. We've talked about that before. Everyone feels confident about it. But now, we mentioned not enough people are doing LED, are doing controls. And this slide really shows that there was roughly 43% savings after they installed the LEDs by installing controls. So again, that is just only against the LED baseline. And again, tuning provided about 21% of that, and occupancy sensors provided the other 21% of that. And as I mentioned earlier, the building itself didn't really allow for significant daylighting, so therefore it's just shown as negligible at the moment. Next slide, please. So as I've mentioned earlier, not enough controls are being installed. One of the reasons why is there's the perception of cost. Often I've been on parts of projects where really even basic controls, contractors have estimated an additional hour or two per fixture for the installation and commissioning of the equipment, even though we try to provide ample documentation that that is not entirely accurate. Contractors are nervous. Obviously, a punch list can hurt their bottom line if they have to keep coming back for commissioning and or other issues. So it's important to pay attention to really what's realistic for controls and try to make sure that they're doing that accurately when they're doing the bid. In this case, it was about 10 to 15 minutes additional time for the add-on controls. So it's much lower than what people might expect, and so I would definitely try to really hone in on those type of numbers. In addition to the controls, it occurred on both retrofit kits and replacement fixtures. So not all the zones were new fixtures. Some were kits. If you're not familiar with those, you just pull out the fluorescent lamps and ballasts and sockets, and they quickly install the parts back in, and it becomes an LED fixture, but just retrofitted there. The retrofit kits, they don't take that long. The 5 minutes that manufacturers claim, it's pretty realistic. Obviously, the first one does take usually 20 to 30 minutes, but once they learn the process, by the time they're doing 800 fixtures, they're really moving along. The also nice thing about retrofit kits is that you don't need the same level of skilled labor, so an electrician can often use a junior assistant to do the retrofit kits versus having to use the more expensive, higher skilled labor to do a new fixture. So that's something also to consider when you're doing installation. But overall, controls shouldn't take you a long time, and we're seeing a lot of controls now come ready as part of a light fixture, all integrated in one or in the kit. So again, that's another reason why controls should not be a significant additional cost, is that most of the light fixtures are now coming with them. Next slide, please. I think the biggest thing to understand, though, anytime we talk about pricing, is that LED fixture costs are changing rapidly and very widely. Famously, the lighting industry really goes out of their way to make pricing horrible. One issue is that regionality plays in a role. I'm currently located in New York, and if you were in Florida or in Texas, where the site project took place, the exact same fixture could have 3 different prices. Similarly, if I was ordering 10 and you were ordering 100, the quantity matters just as much. Finally, because lighting equipment is sold through what's called manufacturer's representatives. They're essentially an intermediate that plays a role with the distributor. If you happen to be buying 4 products from 2 different lines that manufacturer's representative offers, you probably get better pricing as well. So as a result, the lighting industry pricing is really scattershot, and you really need to pay attention to your area of what you're getting and a number of factors. So so the numbers we give you are just kind of a reference point, but they're all going to vary based on your spot, that type of thing. Someone did ask a question about retrofit bulbs having a shorter life than new fixtures. I think that's a great time to talk about that here. Often people ask, well, what about cost? So you can get it what's called a T-LED. That's a tubular LED. It's a replacement for a fluorescent lamp. Realistically, you can get it for about $12 to $18. It is going to have a shorter life than an LED fixture or an LED retrofit kit. The reason is that retrofit bulbs are about roughly 1 inch in diameter because that's what a T8 is. And as a result, that's a lot of material to put in a small form factor. So you have to not only get out your light output, as well as get all your heat management and all of your electronics in a very tight form factor. Also, that in a retrofit bulb, you're often using the existing ballast or other infrastructure, and therefore you can't just wick away heat as well. So when possible, we recommend always retrofit kits or new fixtures just because you're going to get better light output and better life characteristics from that technology. Next slide. As we're advancing to the next slide, someone asked about if there are T-LEDs with high-end trim. First, high-end trim and task tuning are roughly the same terminology, just different people use different terms. The challenge with T-LEDs is that if you don't have the control wiring already to the fluorescent fixture, the tuning doesn't function. So there are some T-LEDs out there now that have a wireless capability, so that way I could walk around with a local device such as a smartphone where I could quickly tune them directly, but those are less common. Most T-LEDs are static output, meaning whatever the rating on the box is, that's how much they put out. So no, to answer your question, virtually no T-LEDs offer the ability of high-end trim. There are some T-LEDs that dim, but again, if your fixture didn't already have that dimming capability, you don't have that at all. All right, so we talked about costs and incremental savings. This chart shows it all. As I mentioned, we had 4 or 5 different zones. And I think this is important to understand that, so even in the same building, energy use varied. But again, this is the LED baseline. So again, the first row is EUI, that's kWh per square foot. Remember that zone 4, I told you that they really tuned it down because the occupants in that space wanted it less bright, and therefore that's why that value is as low as it is compared to the other zones. The savings was varied. This is the second row kind of shows that. Previously, I said it was about 25 to 75% for controls. You're right in that area between 37 and 50 or 60%, and it all varies by what's going on in the building and those type of things. And you can kind of see what the annual savings are per square foot. That's the fourth row. And then this chart essentially says, what if costs were about 65 cents a square foot or $65 a fixture? This then gives you what the payback would be. So if the costs were that low, which will not entirely be the same in every site, they could be as low as 5 years, or as maybe the payback might be 13 or 14 years. Next slide. I think it's important to understand kind of the relationships here. So this chart shows the energy use intensity on the x-axis, and on the y-axis what the cost per square foot would be to meet the requirement. The three horizontal or angled lines are different electricity rates: 7 cents, which happens to be what it was in Fort Worth; 11 cents, which is roughly the national average; and 14 cents, which is realistic for about 10 different GSA states where GSA sites are or higher. And what's important to see is that as your EUI, which is your x-axis, gets lower, your costs also have to get lower. And the reason for that is that you have less material to work with. And by material, I mean energy. And so if you can't monetize those savings, you just can't. Your cost of controls have to get lower as well. So that's why those three lines are all angled. So 1.5 kilowatt hours per square foot is roughly the P100 minimum. If you work through the lighting requirements in P100, that's basically how you get to that value. And so it's just showing you what that line is and showing you that for, for 11 cents a kilowatt hour and assuming about 40% energy savings from controls, you need to be at about 68 cents a square foot for controls to get a 10-year payback. So this is just trying to show you the relationship between all those different variables. Next slide, please. The recommendations for advanced lighting controls obviously focus on wherever your utility rates are higher. If you're above 11 cents, it should be really easy, almost a no-brainer. Sometimes if your facility already has lighting controls, those are already saving you energy, so it may not be helpful. So if your building doesn't have controls, that's also something to think about. Any place that your EUI is high, GSA, some of the facilities are higher than 3 kilowatt hours per square foot. That's also a slam dunk. Again, that gives you more to save with. And then open offices where occupants engage in a variety of tasks. And there's been a fair amount of questions earlier about TLEDs. So if you can't do lighting controls and if advanced lighting controls are not cost effective, we definitely encourage lighting systems that are hopefully future proof, and either these are fixtures or kits that have 0 to 10 drivers. And that 0 to 10 volt drivers, that means it can accept a signal that helps them dim. So that's something to think about. If you can't do controls now, they might be readily in the future. And tuning can always be a key to occupant satisfaction. Next slide, please. Someone asked a great question about our M&V process. Yeah, all the zones were separated out. So we measured both at the panel level and at the fixture level. So everything was separated when we calculated those types of things. Tuning, can't say this enough. Tune light levels to meet occupant needs. Yes, it saves energy. It improves the quality of light. It's also not always implemented, so it's definitely something to think about. Previously, with fluorescent technology, it was expensive and hard, actually. With LEDs, almost all LED fixtures or kits come dimmable right now, so tuning is pretty easy. And then some manufacturers, they can even tune at the factory. You can say, oh, I want this quantity of fixtures to be output at this level. And why, you might say, well, why is that? Well, we're finding that some manufacturers are reducing the number of products they offer. And so because dimming LED technology is so easy to dim and they can do different features for it, they reduce the number of SKUs they have by just offering one fixture at kind of 2 output levels. And therefore, you might want to specify that from the get-go, or you can do it on site. Next slide, please. Someone's asking a great question about demand response. Demand response, totally always encourage things to do. One of the values in advanced lighting controls is that because it can already dim, you can dim your lights by 30% before your occupants can really perceive it. And that's what demand response really comes in. So if you, depending on how your demand signal works, and you can work with your manufacturer on your demand response, you can easily take advantage of that function where on high demand days, dim the fixture by easily 30%, and no one would really even have any negative side effects as a reduction in light output. You can't really do that with HVAC and other technologies. So just touch base on, again, tuning a little more. Manufacturers incorporate task tuning as a standard option in the configuration. This is often found in their apps and their software. So this is a pretty standard feature now. Contractors should include it as a standard installation step, not to forget it. But as a result, you might want to have a light meter handy when your contractor or your commissioning agent is doing it. Just going off the perception of, yes, this feels bright, if you're not doing it at the right time of day, which I would encourage you not to do it when there's no daylight out, or B, you don't have the right amount of occupants in the space. If you have one contractor go room to room just kind of eyeballing it, you're probably not going to get the results you want. So you either want to commission based on with actually an illuminance meter or with the people in the office, but that may not be easy just because of getting them in the evening hours and some of the other logistical things. Specifiers, procurement, end users require task tuning in your specs and also in your punch list. Again, it's pretty easy. Most cut sheets already have it as a feature. You should be able to ask it. And then utilities, they support tuning in their programs. You can start finding it a little more in the utility rebates. It might be in a custom program, so you have to pay attention to it a little more. Can you go to the next slide, please? So this is an online tool that was developed called the Advanced Lighting Calculator. It's on the URL listed there. The idea here is that you can kind of specify the energy savings that you think you're going to get from the different types of controls or that you want to get. It allows you a lot of features. And then you can actually input how many days it's operating as well as how many hours it's operating and your electricity rate, and then what the cost of your controls are. And what it will do is it'll essentially give you a payback. So the idea here is that if a manufacturer quotes you a price using either inputs that you have found or that you think are right or previous experience on other projects, you can then essentially reverse engineer whether or not that project will, the controls will be cost effective for the price that they're providing you. A general rule is at least, it's pretty general rule, is that one fixture per 100 square feet. So we've been using pretty interchangeably $65 a control point and 65 cents a square foot. It will all vary on the fixture type and some other considerations, but if you were doing any estimating guides or those type of things, that's a pretty fair number to use as a starting point. Obviously, the more you know, the more accurate this is going to get. At this time, the presentation will be continued on by Frank Campagna and Stuart Lampkin. Next slide, please, who were both on the ground in GSA Region 7 and can provide their perspective.
Good morning, everybody, from beautiful downtown Fort Worth. This is Frank Campagna and Stuart Lampkin. I was project manager on the ground for Region 7. Stuart, at the time, was the building manager for this property. And I just want to start out by saying thank you to Kevin Powell and Jay Fine for their support and leadership throughout this process. This was a pretty huge undertaking. And without their mentoring and giving me and Stuart advice along the way, it wouldn't have been as successful as it was. But as I said, this was a pretty daunting project. We essentially broke all the zones out, and we found vendors that were willing to work with us and willing to go through the process. One of the first things we asked them to do is do some homework. We gave them some lighting power densities that were prescribed by our P100, which is our standards and facilities guidelines. And we asked them to put together a photometric point by point for each space that they were given. When they came back and submitted them to us, and we approved or we advised, but at the end of the day, it was done. in accordance to how they put the point by point together. So essentially, after that was done, we did some town halls with all the occupants. We had town halls throughout the entirety of the project. We had one before, in the middle, and after. We always kept our occupants tuned into exactly what we were trying to get done with this project. We also had mock-ups installed in all the different zones so that the occupants could see that what was coming. They could basically kick the tires, and you know, if they had any questions, tears or jeers, they could let them be known to us before we installed the rest of the project. But as Mr. Myers alluded to earlier, we went down from essentially 1,250 fixtures down to 850 fixtures. So that was a pretty daunting task to remove or realign, readjust all the reflective ceiling plans in these zones. Some of the other challenges that we faced were, you know, just the building's age was very old. There was a space above the ceiling grid that was between the ceiling grid and the deck was like 30 feet. So we had all kinds of debris coming down from the ceiling once we removed the fixtures. We had a fantastic installation company that did everything in their power to keep the mess down to a minimum. As a matter of fact, and Stuart could get into this more, we hardly had any complaints about cleanup. So anyway, let's go on to the next slide. Let's see what else we got going on here. Yeah, this is just one of the wireless control routers. I don't remember which one this is, but this enclosure has some wireless routers that communicate with several different hubs in each zone. Each hub operates a number of group fixtures. Next slide, please. Yeah, this is one particular controls vendor that we use and lighted that, and the graphic shows you the granular information that you can receive here on how the HVAC space is utilized, the energy savings. Each color represents a different point. And we just presented here to show you how much detail you can get from any one of these advanced lighting controls. Next, please. Flow Lighting was another vendor that we used. What I liked about them is that we can walk around with a tablet and actually drill down to one or two fixtures. I think Mr. Meyer alluded to earlier that you can get down to the user controlling their lights over their desks. You have that functionality with their control system. Next, please. RAB and Patriot Lighting teamed up with Lutron Controls. I believe they used the Vibe system. Had very good success with their controls. They're user-friendly, and they have the capability of adding on more functionality and more fixtures if need be. Next slide, please. Philips was one of the first ones we got to turn on because it was a very easy installation. It basically uses that remote control. You have to point it at each fixture, and then you can commission one fixture at a time. They also had some, as did Lutron and IntelliLume, they had these wireless switches that were installed, and the old high voltage switches were removed or capped off, and we actually replaced by wireless switches. And one nice thing about that functionality is if you change the configuration of a floor plan and you have to move that switch, you just basically peel it off the wall and slap it somewhere else where it's a little easier to get to. And that's the case with all the lighting controls that we use, not just Philips. Next slide, please. Yeah, this particular building was it's a subsidiary of USDA, NRCS. They do a lot of soil sampling. They test a lot of things, and they like being dark. So when we redid all the reflective ceiling plans, all the LED fixtures, whether they were new or kits, were at 100% capability, and we really rocked their world. So they weren't very happy with us when we first turned the lights on, but we did gain their confidence, and they actually gave a lot of compliments once the fixtures were all fine-tuned, and we actually were able to tune them to each user's preference. So very important, the fine-tuning aspect of it. LEDs have a different directionality, and it's just a different lighting, and you get different opinions about it. But with the fine-tuning aspect of the advanced wireless controls, it really saved the day in this particular application because they did like it dark, and we were able to bring the dimming down quite a bit. Next slide, please. Yeah, just a couple of things on this. We did use an island approach. It was not behind our firewall. We have to bench test everything that goes behind our firewall for hacking, issues. So at that time, there was maybe one system that had been adjudicated, so we took the island approach. It was not behind our firewall. We constantly receive firmware updates. We have to do it on site because they're not behind our firewall. And some of the companies, like I alluded to earlier, that participated were Enlighted and Flow Lighting, Technical Solutions, Lutron, Philips, now Signify. They have recently cleared our adjudication process, so congratulations to them. We can now place them behind our firewall. So I don't want to take up too much of the time. I want Stuart to give some feedback. He was, like I said earlier, he was the building manager. I really rocked his world when I came in and upset the apple cart with the lighting. Nobody pays attention to lighting until it goes out over their head. So anyway, Stuart, what was your biggest takeaway as a building manager?
Yeah, so biggest takeaway, whenever you change the lighting environment for an office space, people do notice and they complain right away. And so the biggest takeaway for this project is the benefit of being able to adjust the lighting with these advanced lighting controls. As Frank had stated earlier, when we had first initially installed all the LED fixtures and they were at 100%, we got a ton of complaints from people specifically for this building. They don't have a lot of windows. In that one picture earlier, you saw some windows, but that's just one small area of the building. The majority of the building does not have windows at all, and so any change in light is significant in their perspective. So having the ability to dim the fixtures to the occupant based off of the occupant feedback is a huge benefit for these controls. As Frank had mentioned, doing the town hall meetings was a good way of getting buy-in to this project. Another conversation that would have to take place after the fact too is how requests for changing lights is going to be handled through the O&M. I made sure that the tenants understood that it's not it's not because you come in and you have a migraine that the O&M is going to come and change the lighting for you or dim it down. We kind of dimmed it in groups with this project. There is the capability of people having control of the lights, but for most part, we're going to set it up in groups and change the dimming capabilities in a group of fixtures, not just one fixture, because this office space that we were dealing with was mainly open office space with cubicles. So you're really not going to change one fixture at a time. Although you do have the capability with these controls to do that. I think that just opens up a can of worms for property management and the O&M. So those are conversations that just need to be taking place after the fact of how that's going to be handled and so on. So that's really all I had. Again, the dimming capabilities is really what helps sell these advanced controls, being able to dim it to whatever the tenant is, whatever their preference is.
You know, and before I turn the mic over, I would just mention a couple of things, good practices, lessons learned kind of a thing. You know, if you have high ceilings, high furniture, high cubicle furniture, and low ceilings, you don't want to get overly aggressive with your spacing of your fixtures. We found out it creates way too much shadowing. So even though we had a photometric that said, you know, you could do X amount of spacing, when we actually installed it, it just wasn't so because of the existing scenario with the high furniture and the low ceiling. So that's something you definitely want to take into consideration when you're considering doing a change to your reflective ceiling plan on an existing one. And I think I heard someone mention before, it's always a good idea to do before and after foot candle readings. It's always a good idea to do mock-ups, and you just cannot get enough information from the occupants themselves. They're the ones who have to live with it, so you can save yourself some grief in the long run if you do some front-end communication with them right from the get-go. And that's basically all I have. It was a fantastic project, probably one of the most tedious ones that I ever was involved with lighting-wise. But I think everybody who participated with it learned something from it, and I hope you guys can benefit from what we did here. We really have used it in a number of places throughout the region, used our takeaways. And again, thanks again to Jay, and I'll turn it back over to you. I appreciate all your mentorship, Jay, throughout the process, and that's all we got to say.
Great. Thank you, Frank, and great job, everybody. That was a fantastic presentation. We have about 7 minutes left, and we have a few questions, so I want to go ahead and jump into those. Frank, let's start with you. There was a question during your presentation. Can you quickly just explain what you meant by islanded approach?
Yes. Basically, there's all the controls, the wireless controls, the transmission portion were all independent of our building automation system or the GSA network. They were standalone. In other words, you know, the Lutrons, controlled Lutrons, hubs and sensors, and lighting the same, and flow lighting and Philips. They were all independent of each other, and they were all standalone on their own merits, and they were not part of the GSA network. Hopefully that makes sense.
Perfect. Great. Thank you. All right, so I'm going back to some of the very first questions. These were actually covered later in, but I just want to make sure we're clear about that. So one of the questions was about, of the lighting vendors that participated, how many of them made it on the PBS IT approved products list? So Frank covered this. Philips and Lighted, Lutron, and Flow all made it through our GSA IT security clearance process. And then there's another question that's similar, I think, which said, how about lighting controls in hyper-secure places like USCG command centers? So the same thing. So for us, on our end, for GSA, you know, as long as they're IT security cleared, you can put those in those spaces. Of course, your customers may have unique requirements or other needs or restrictions, so you have to pay attention to that as well. Our evaluation didn't deal with the Coast Guard, so we can't address that specifically here. Another question was, for light level tuning, it's set at a certain point and can only be changed by the O&M. So, Michael, do you want to address that for us?
Just the concept there is that depending on how the system's set up, you know, in this case, the example was with an iPad or a tablet, it's not an active thing where the tuning's changed every day where I come in where I feel like I want a lighter or brighter. It's happened more at the either building manager level or something like that. So that all depends on the style of lighting configuration you do. You can do it where your occupants do have direct control of your fixture even on a daily basis, but that often requires more coordination, and sometimes that can even run into its own IT issues of how do they talk to the fixture. So there are different ways to do it, but these were all left at the commissioning time or the O&M side, yes.
Great. And then keep yourself off mute. I'm going to ask you to help with this one as well. Do day-to-day wholesale lighting changes building-wide ever present power factor challenges?
In general, I mean, power factor is really a function of the equipment installed. So if I replace fluorescent and I install LED, offhand, I would not expect a wholesale change to cause a problem. Most LEDs have high power factor power supplies already, so that's not really too much of an issue.
Okay, great. And then this one I think is also good for you, Michael. What's the price difference between LED retrofit kit versus new lighting fixture? Also, is there any difference in lighting level between retrofit and new?
Great. So I'll kind of step up three. So the TLEDs, as I mentioned earlier, are about $12 to about $18 per tube. You're going to have 2 or 3 in a fixture, so that's the TLED option's about $30 to $40 right offhand. Kits, I've seen them in the $70 to $95 range. New fixtures, I've seen as low as $105 to upwards of $200 to $400. The fixtures can get more expensive depending on really appearance, not performance. So that's the type of things. In terms of light output, kits and fixtures, they almost all are very comparable head-to-head on almost all functions of light output.
Okay, excellent. And then I'm going to make this the last question. There's a few questions in addition to this, but I think they're a little off topic and not really related to specifically this presentation. So for the sake of time, I'm going to cut those out. Michael, this is yours, though. Were all new fixtures retrofit kits BAA compliant?
So BAA is Buy American Act. I don't have that level of detail everywhere. I believe, and I don't know our follow-up mechanism, but we can look into that. But offhand, I believe, yes, they were. And that just means, by the way, for those who are not familiar, that a portion of it is manufactured either in the United States or in a participating country. So if you read BAA language, also we have what are called mutually recognized treaties, and one of those, NAFTA is an example. So if the product is manufactured actually in Mexico, it does meet BAA because of the secondary provision. So if you're very concerned about BAA, I would definitely read the whole thing and see what countries and locations and portions of fixtures are required to be constructed where. But I believe all 5 of these products were, yes.
Yeah, and I just want to dovetail to that and say that it was a requirement in our scope of work to be a BAA compliant, so just to reinforce it.
Great, excellent. Okay, great job, all the presenters, fantastic job today. You did a terrific job. Andrea, I'll turn it back to you to close us out.
Great, thank you. Yeah, I want to just reiterate what Jay said. Really great job. Thanks for all the excellent questions from the participants as well. So you all should be receiving a survey in about 15 minutes. It's about 5 questions. We both really appreciate your feedback, and that's also how you can request continuing education credit. If you don't receive the survey, please contact Michael Hobson. And we will also be sending out a link to the presentation slides as well as a link to the recording You should receive that sometime next week. It may happen the week after because of Thanksgiving, and that will also have answers to the top questions and answers. So thank you again for all your participation and presentations, and we look forward to seeing you at the next webinar in January. Bye.